Hey guys, today we're going to discuss reactions in aqueous solution. This corresponds directly to section 11.3 in your textbook. Just as a quick reminder, RXN stands for reaction and SOLN refers to the word solution. So this says reactions in aqueous solutions. So first thing that we need to discuss is just some basic reminder things about reactions. We already have discussed that the left side of a reaction is called the reactant side and that the right side is called the product side. The left side is kind of like the ingredients of making something, so the eggs, the flour, the butter. The right side is what we make. Cake and some broken eggshells and maybe even an empty cake box. So, first thing that I want to show you is that you have silver nitrate combining with sodium chloride, and it's going to make silver chloride and sodium nitrate. Note that these three, the ones that are underlined in blue, have the symbol AQ beside them. AQ stands for aqueous. It means that a substance is dissolved in water. And so we're using a liquid in order to deliver these chemicals instead of a typical solid. Also, that these particular substances, because they're dissolved in water, when they're reacting, they're actually broken up into ions. So we really don't see Ag and NO3 reacting. If we were to be shrunken down to the size of a molecule, we would actually see Ag plus, and separately somewhere else is NO3 minus. Think of it kind of like a couple, a married couple at a cookout. So they're married and they came in together, but the reality of it is while they're there, they socialize with different groups of people. And so, you know, the men might be outside by the grill and the ladies might be in the kitchen and mingling around. Again, they come in together, but in the actual chemical reaction, they're breaking up into their ions. The S stands for solid. These are things that will not break up in solution and they actually stay together. When you have a solid on the product side and there weren't any solids on the reactant side, we call that a precipitate. Very similar to precipitation like rain or sleet or snow. In that particular case, we have gas, air, and out of nowhere we have this liquid that forms. Or out of nowhere, we have this solid that forms in the case of sleet or snow. So this is very similar to that. Usually what that means is that the container, which might be clear, is now cloudy, or you might see flakes, or you might see crystals form. That's the type of solid we're referring to. I'll show you a couple of examples of this in class. So now we're ready to talk about complete ionic equations. So, first of all the aqueous substances are going to split. So this AgNO3 that was here is now going to split into Ag plus and NO3 minus. The NaCl is going to split into Na plus and Cl minus. And we know these charges because we have our polyatomic ion table and we've memorized the charges. NaNO3 is also going to split into Na plus and NO3 minus. Now, that one that was solid, it's going to stay together as AgCl. While we're here, let's talk about something called spectator ions. Spectator ions are the ions that are in the solution but really don't take part of in the reaction. An explanation would be, or an analogy would be, if two people are going to fight, for instance. Hopefully that wouldn't happen in school, but occasionally it does. And if two people were to fight and you have one person who kind of is the go-between and tells the other one what's going on, or what someone else said, they're kind of involved in a way. But when it comes down to suspensions and things like that happening as a repercussion of their actions, the spectator ions don't really take part. So these guys are the same on both sides. You have NO3 over here, you have NO3 over here, you have Na over here, you have Na over here. So they started in the reaction as reactants and they're also products. We would consider that to be a spectator ion. I've circled those for you in green. Now that we've discussed spectator ions, we now can start to talk about getting our net ionic equation. So basically, we cancel all of the spectator ions that are in our reaction. So if you look carefully, everything that was in green gets kind of crossed out. So our Ag plus that is there, it stays, but our NO3 and our Na plus, since they appear on both sides, are canceled. we are still leaving together our AgNO3, or a silver chloride. We're going to rewrite that, getting rid of these spectator ions, and that would look like this. And you can actually see that I actually went back and put in my aqueous, my AQs. I didn't do that before because it gets to be a little overwhelming with all the parentheses and the letters that are lower. Typically it helps if you make it shorter. So just make sure that you put the S there for solid, and then when you get back to the end, you can rewrite it and add it in. After you get this equation, that's the point where you would balance. Now this particular one is completely balanced, and so our final answer is Ag plus aqueous plus Cl minus aqueous yields AgCl, solid. So even though sodium and nitrate were in the solution and they were part of the reactants, because they were also part of the products, they did not take part in the reaction, and we do not show them in the final answer. Just a couple other things to go along with this. When you're talking about forming precipitate, there are rules that say when things are going to clump together and form a solid or a precipitate, and when they're going to dissolve. There's a table on 11.3, and that's on page 344 in your textbook. Look at that table. You will get it on the test, so it's not something you have to memorize. But what you should know is that anything that says soluble means that it's aqueous in water, so it splits up in water. And anything that's insoluble means that it won't dissolve. So for instance, if you look at that table, you can see that all things from the first column of the elements. So if sodium, if sodium, potassium, or lithium are in something, those things are always soluble. So soluble means that this is going to split up in Na plus and Cl minus. Now, if looking at that table on page 344, if you scroll all the way to the bottom, it says that carbonates are typically insoluble. Well, they're insoluble except when they're paired with something from the first column. So in that case, since this is a carbonate, calcium carbonate, which is chalk, calcium carbonate is insoluble because this is not a first group element. We're going to work more with this in class, so don't worry about that part. But what I do want you to know is to be aware that you will not have to memorize that table, and it will be given to you on a test. Let's do an example together. So what I would like you to do is to pause now and underline all of the things that have AQs beside them. Those are the things that are going to split up. And if you have at home, if you have multiple colors, then you can use two different colors. Because I will assume that you don't, you just have your pencil, we're going to say underline the things that are aqueous. Pause now and take care of that. You should have underlined the lead nitrate, the sulfuric acid, and the nitric acid. The next thing that I'd like you to do is to draw a box around the thing that's going to be solid. And in this case, that's going to be our lead sulfate. Our next step is to rewrite this such that everything that is together stays together, so our solid that we put in a box, and everything that splits apart, splits apart. Pause now, and you work on that. So you should have gotten this. Don't worry about balancing anything at this point. Your goal is simply to split things up. We don't balance into the last step. So now we're going to look carefully at our list. We're going to look for things that are the same on both sides. You pause right now and see if you can circle the things that are the same on both sides. I see that the nitrate is the same on both sides. and that actually should be a minus. This is one of the great reasons why we often write in pencil, so we can fix mistakes easily. And I also see that the H plus is the same. So if the question asks what are your spectator ions, you could say H plus and NO3 minus. Now we're going to write now this is our complete ionic equation. Okay. Now let's move to our net ionic equation. And to get our net ionic equation, our goal is going to be to eliminate all of our spectator ions. So all the things that are circled in green, we're not going to write those twice. Pause now and rewrite this equation so that you've eliminated the things that are in green. Eliminate your spectator ions. This is what I got. At this point, we're going to double check to make sure that everything is balanced. We're going to add in our little AQs. And this is our final net ionic equation. Okay. We're all done. Make sure that you go online and that you complete the Google form that I'll link at the bottom of the description box. Thanks so much. See you next time.